Hello fellow IB chemistry students. Today I'm here to talk to you guys about calories. You guys may know about calories from experiments that we've done and that require energy, but we're here to talk about calories as they apply to food. It's a very similar concept, a calorie still being the unit of energy required to raise 1 gram of water 1 degree Celsius, but there's a few differences. When you look at the back of a food label and you see calories, those are not actually calories, but kilocalories rather, which is 1,000 times more than a calorie. Another common misconception is that calories are not all created equally. You may read in food articles online or in dieting articles that you want to put these calories in your body instead of those calories, but it's all the same thing, and it's all the same amount of energy. Now that we've got those cleared out of the way, let's move on to how we measure calories and what makes food have more calories. This is a food label. A food label contains the total amount of calories in an item. But calories don't just come out of the middle of nowhere. Calories are actually contained in specific items on the food label. After all, they are energy, and energy has to be stored somewhere. These items are the fat, carbohydrates, and proteins. I'll show you how to use these values in order to come up with the total amount of calories for an item which you have these three values, but you do not have the calories. This is called the Atwater method. Okay, now I'm going to show you guys how to do the Atwater method. The Atwater method is, the base of the Atwater method is that carbohydrates, fats, and proteins are all going to hold the same amount of energy, or calories. Let's take a serving of food with 12 grams of fat, 24 grams of carbohydrates, and 10 grams of protein. To find the amount of calories that come from each, first multiply the amount of grams of protein by 4, fat by 9, and carbohydrates by 4, minus the insoluble fiber. After you do this, you get the total amount of calories that come from each. The reason you subtract insoluble fiber is because insoluble fiber is basically carbohydrates that don't hold any energy. Once you add all these numbers up, you get the answer, which happens to be for this food, 240 calories. The advantages of the Atwater method are that you don't need to do an experiment to find the number of calories. However, it doesn't explain the science behind calorimetry in food. Here we have a bomb calorimeter that can be used to find the number of calories in a certain food. It works by burning a sample of food in a cage filled with O2 to heat up the surrounding water. Once the sample stops burning, you can measure the change of temperature of the water to find the amount of calories in the sample with the following formula. You may recognize this from labs that we've done previously in this class. Yep, the formula is Q equals MCAT, or Q equals the mass times the change of temperature times the specific heat capacity of water, which we would be using as 1 calorie per gram per degree Celsius. Okay, now that we've learned about the Atwater method and the bomb calorimeter method, keep in mind that you need to be putting in your body what you want to get out of your body. Our bodies are basically just a series of chemical reactions that happen in order for our body to function. Meaning that if you don't put enough energy in, then you can't retain the same mass and your body won't continue to function properly. Even though energy in your body may seem different than energy from chemical reactions, they're very much the same, as we saw when we were using the bomb calorimeter method with Q equals MCAT. That being said, go share your knowledge with your chemistry buddies and impress people and make sure you eat enough food and get the right energy. And looks like we're done here. Thank you guys for watching. Roll the music.
I'm a machine, you're a machine. Everybody that you know, they are machines. To keep your engine running, you need energy. For your high-powered revved up body machine. Your high-powered revved up body machine. Now, I'd be a fool if I said that the fuel that we needed to burn was